Angles are everywhere around us. They are used by engineers, architects, and artists to invent creative solutions to specialized problems and to create beautiful fixtures and works of art. Many times, the angles present in shapes and intersecting lines have relationships with each other that we can use to determine their measure. One such relationship is congruence. If we say that two angles are congruent, we mean that they have the same measure in degrees. For example, suppose we build a square room where all the corners are 90 degrees. Its four corners would all have congruent angles because they are all the same measure. Similarly, we know an isosceles triangle has two angles with the same measure. These two angles are therefore congruent. To denote that some angles are congruent to each other, we usually draw an arc in the angles. Congruent angles really start popping up when we observe the intersections of straight lines. For example, if one straight line intersects another as shown, we can see that there are pairs of congruent angles created opposite to each other. Because both lines are straight, the angles on each side are basically mirrored, so that the red angles are congruent and the blue angles are congruent. We call these angles vertical angles. It is also helpful to note that because the lines are straight, two adjacent angles together form a straight angle of 180 degrees. This property will come in handy when you need to solve for missing angles. Let's try an example. If angle A is 40 degrees, what are the measures of angles B, C, and D? Because the two intersecting lines are both straight, we know that the opposite angles A and C are congruent. Therefore, C must be 40 degrees as well. Similarly, angles B and D are congruent. Their measures can be determined by using the fact that A plus B must equal 180 degrees. So if A plus B equals 180 degrees and A is equal to 40 degrees, we now have 40 degrees plus B is equal to 180 degrees, which we can then solve to get B is equal to 140 degrees. So B and D must both have measures of 140 degrees. What happens when we observe two parallel lines that are intersected by a third line? Consider the parallel lines P and Q and the transversal line T that cuts across them. We now observe two intersections and a total of 8 angles. A close look at these intersections reveals that they are identical to each other. Because P and Q are parallel, their intersections with T form congruent angles. So not only are angles 1 and 3 congruent, but angles 5 and 7 are also included in the same congruence. Likewise, angles 2, 4, 6, and 8 are all congruent. There are 4 classifications for the types of congruent angles present in this scenario: vertical angles, corresponding angles, alternate exterior angles, and alternate interior angles. Vertical angles are those which are opposite each other at a single intersection point. This is like what we observed in the earlier example. Here we see that angles 1 and 3 are again congruent, and because they are opposite each other at the same intersection, they are classified as vertical angles. Similarly, the pairs of angles 2 and 4, 5 and 7, and 6 and 8 are all vertical angle pairs. Corresponding angles are pairs of angles in the same relative position of the intersection of each parallel line and transversal. Corresponding angles are congruent to each other. For example, angles 2 and 6 are corresponding angles because they both appear to the right of T and above the parallel lines. So they are congruent angles. Other pairs of corresponding angles in this example are angles 1 and 5, 3 and 7, and 4 and 8. Alternate exterior angles are pairs of angles that appear on the outsides of the parallel lines and on opposite sides of the transversal. Alternate exterior angles are congruent to each other. Angles 1 and 7 are alternate exterior angles and are therefore congruent to each other. Angles 2 and 8 are also alternate exterior angles, making them congruent to each other too. Similarly, alternate interior angles are pairs of angles which appear on the inside of the parallel lines and on opposite sides of the transversal. Alternate interior angles are congruent to each other. Here, that would be the pairs 3 and 5 and 4 and 6. We've discussed that 2 or more angles are congruent if they share the same angle measure, and we have looked at a few geometric applications of these congruent angles. These ideas help builders, carpenters, and engineers ensure perfection in their work as they design tools, objects, and buildings. Take some time to work through some example problems on your own, and you'll soon be seeing congruent angles in the world all around you. I hope this video was helpful. Thanks for watching, and happy studying!